Welcome to this video on functions. So what is a function? All a function is two mathematical expressions set equal to each other with one input, one output, and it's required to be defined on domain. Okay, and we will get into this definition of domain here soon, but let's just show you what a function is often written like. So it'll often be written as f of x. Okay, this is the notation that a lot of textbooks and what professors might use for functions. So if you see f of x, you know function, right? Like all caps, you know this is a function. Nobody needs to tell you. The other way this can be written is just using y, right? These are equal. Those are the same thing. Y and f of x are the exact same thing. So let's just do x squared plus 3x plus 2. Okay? So this is going to be your output, and x is going to be your input. Okay? And you can have multiple x's in the same function, right? But you can't have multiple inputs. I hope that makes sense. Okay? So now that we know what a function looks like, what is this domain that I'm talking about? Well, the domain is the set of all possible input values, okay? And your input values is your x, right? Your domain, if we're talking about graphically, right? This will always be your x-axis. This will always be related to your x-axis. Okay. Now we have range. Okay, so we said the domain is the set of all possible input values. So range is most likely the set of all output values. And that makes sense. Okay. So let me just show you an example of how to use this domain and range. So let's have an example. We'll say f of x equals root x minus 10. Okay, so this is a function. I'll tell you it's a function. But where is it defined at? What is the domain? What is the all possible input values that can go into this function? Well, for a fact, I know we cannot have a negative square root. This is bad. Equals bad, right? You don't want this. You want your square root to always be positive. 0 or greater, right? So if I know I want it to be 0 or greater, I can just set this equal to the smallest value that is possible, which is 0. Okay, and I'm just going to solve for x. So square both sides, 0 squared equals x minus 10. Add 10 to 0 squared, which is just 10. And we have 10 equals x, right? So we know 10 is going to be the smallest value, because of that subtraction sign, because we don't want it to be less than our square root to be negative. So we know 10 is the absolute smallest value that our domain can be. So how should we write our domain? What notation should we use? So when you're writing a domain and you're writing an interval here, we will 10's the smallest, so we can go 10 to infinity, right? And why do I use this square bracket? Square bracket means includes point, right? If I use a round bracket like this, or a parenthesis, excuse me, this means approaches value. And maybe I should say approaches includes value, not point, but the reason we can never include infinity is because infinity is not a tangible number. It's not something we can define. It's not a definable number. So it's just approaching infinity, okay? So what about our range here? So our range, we know we can't have a negative square root, so 0 is going to be the smallest value. So it'd be 0, and it's defined everywhere else. So 0 to infinity, right? Okay. And let's do one more example for domain and range. So let's just come up with an example real quick. We'll say f of x equals 1 over x. And remember, this is what we're writing. Okay, so here's our output. Here's our input. And remember, input is related to our domain. Okay, so let's look at this. 1 over x. Well, there's one thing I know about 1 over x is we can relate this to 1 over 0. 1 over 0 is undefined. Okay? And that's important. That's very important. Because you're going to have a lot of these domain range problems where you're going to have 1 over x, plus something or minus something, whatever. Okay? But you cannot have 0 in your denominator. So what do we say for a domain? All we say for our domain is x cannot equal 0. Okay, what about our range? What about our y values? What's the set of all possible y values? What are our y values looking like? Well, we'll never hit 0 because 1 over 0 does not equal 0. So we'll never have a chance to actually hit 0. So this will be y cannot equal 0. And this is saying is it's all real numbers. Our domain and range are all real numbers except for 0. Okay, so what does this graph look like of 1 over x? Looks like this. See how it never hits. It also never hits here too. So this is what your domain and range looks like in practical use, but I hope this is making sense to you. If it doesn't, please go check out more of my videos and consider subscribing and liking this video if it helped you out at all.